A 10 kilogram mass is pulled up a slope inclined at an angle of 30 degrees to the horizontal by a force of magnitude 10 g newtons, and here it is, parallel to the slope. The slope is rough, and the coefficient of friction between the mass and the slope ground is a half. So mu is equal to a half. And F is equal to mu r. In other words, the friction force is equal to mu r. So here we are, F is equal to a half by r. The question then says, find in terms of g the acceleration of the mass. So here's our diagram. You have an inclined plane like this. You draw your 30 degrees, you draw your particle, you put in your 10g. You always draw your r, which is perpendicular to the ground that it's on, so it's perpendicular this way. It has the friction force, which is going down the slope, which is equal to half of r. Notice your weight is going straight down to the centre of the earth. So W is equal to 10 Gs, because it's 10 kilogram mass and its weight is equal to 10 Gs. Now, the first thing we're going to do is, when we've drawn your diagram like this, is we're going to resolve this weight force into two other components. One which is going perpendicular to the slope, and one which is going parallel to it. Now, let's start resolving this the weight force into two different components. Once you've gone through this once, you can just use them. You don't have to be able to derive it every time, but just to show you where it comes from. Here's my 30 degrees. I've dropped in a perpendicular from the weight and a parallel across to here. And I'm trying to, my dotted line is the old 10G. Okay, so let's look at the angles. This is a right angle, A here is a right angle, and the angle B and C is a right angle as well. So 30 plus B is equal to 90 degrees, because the whole triangle is 180, so 30 plus B is equal to 90, and B plus C is equal to 90. That means that C is equal to 30, okay? And this is a right angle down here as well, because I dropped it straight down here, and then I went straight across parallel. So that's equal to 90 degrees as well. So this perpendicular component is equal to 10G cosine of 30 degrees. And this parallel component is equal to 10G sine of 30. The way this works is because cosine 30 is equal to adjacent over hypotenuse. So 10G multiplied by this divided by this, and that's the hypotenuse, the 10G is going to cancel out. So you're just left with this magnitude here. And this one is 10G sine 30 in the same way. 10G sine 30, the 10G will be cancelled out by the trig ratio, and we're just left with the value here. So let's see what those values are. So we then replace our weight component with the two new components, the one which is perpendicular to the slope and one which is parallel to the slope. 8.66 is equal to 10G cosine 30. That's equal to 8.66G. And 10G sine 30 is equal to 5G. So we put those into our new diagram. It's important to note that the old 10G weight coming down is now replaced. You must not have a solid line coming down here. You must, when you put in your new components, you dot out the old one to show that it's not relevant anymore. It's been replaced by these two. Okay, our friction force is equal. I decided to add another small f in. Our friction force is equal to half of r, and r is equal to 8.66 g, so that's equal to 4.33 g. The full force then is going to be equal to 10 g, which is here, 10 g is this one, minus a half of r, which is equal to 4.33 g, and minus this 5g as well. Look, I've got the force going this way, I've got the friction going this way, and I've the part of the weight which is in the parallel direction going this way. So I've got minus 10G minus 4.33G minus 5G. And that's equal to, 10 minus this is equal to 0.67G. So now we're trying to work out, I think the question asked us what the mass is, or the acceleration. So okay, so F is equal to ma. So we're going to have 0.67 g is equal to the mass, which I think was equal to 10 kilograms, by the acceleration. We'll just double check that. So there's the mass, 10 kilograms. So let's go back and finish off this. Is equal to 10a. So that means that a is equal to 0.67 g divided by 10, which is equal to 0.067 g. I think the question also says it wants it in terms of g. So it finds in terms of g the acceleration. So there's our answer. Our answer is equal to 0.067 g. And of course, don't forget that that's equal to meters per second squared. There we are. 0.667 g meters per second squared. Now, quite a similar story to the last question. A man drags a particle of mass 100 kilograms over rough ground by means of a rope, so you know there's friction, by means of a rope which makes an angle of A with the horizontal ground. Now, it's flat horizontal ground, but in this case, it's not going up a slope, but his rope is kind of at a slope. So it's kind of, some of his pull will be going into horizontal force, and some of the pull will be going into vertical force. If we set up a triangle with the tan A is equal to 12 over 5, using Pythagoras, well, you may even know that that's equal to 13. So we know that cosine of the angle is equal to adjacent over hypotenuse, which is 5 over 13. And we know that sine of the angle is equal to opposite over hypotenuse, equal to 12 over 13. We know that this force along here is equal to 260 newtons. So therefore, to work out this force in the horizontal way is going to be 260 cosine A, which is 5 over 13. And that gives us the horizontal equals 100 newtons. And then for the vertical, we have 260 sine of A, which is equal to 12 over 13. And that's equal to 240 newtons. Okay, so that's how we do those. Now, our job is to find mu, is to find a coefficient of friction, mu. In order to do that, we know that it's going to be equal to 100 newtons. The reason we know it's 100 newtons is because we're told the particle is just on the point of slipping when the tension in the rope is 260. We've resolved this to give us a horizontal and a vertical. The horizontal is 100 newtons, so mu r is going to be equal to 100. But we want to work out what r is. R is equal to the normal force, which is going to be equal to 980 newtons down here. Okay, take away 240 newtons. So let's see the way it's done on the next slide. So you can read that in a moment yourself. So the normal force, R plus 240, is equal to 980. So R plus 240, because that's going in the same direction as the R, is equal to 980. So R is equal to 240 plus 240 is equal to 980. R is equal to 740. Okay, but R is equal to 740, therefore mu by 740 is equal to 100. Mu is equal to 5 over 37, and that is our answer. Let's see what it says here. In this case, the particle is not moving. Its acceleration is 0 because it was just on the point of movement. By Newton's second law, the force in the particle must be 0. So the total force up must equal the total force down. The force on the left must equal the force to the right.